Welcome to today's workshop, the drip irrigation troubleshooting, maintenance, and repair. Before we get started, just a few things. Again, there is a Q&A section at the bottom of your screen. If you have any questions throughout the workshop, please post them there. We are monitoring them and we will be answering any questions you have. Our speaker is here from the town of Gilbert, Jeff Lee, who is the guru and expert in all things irrigation. And I will hand it over to him and we'll get started.
Good evening, everyone, and thank you for joining us. Today, we're going to be talking about how to take care of your drip irrigation systems, how to make sure they're running the way they should be, and of course, when things go wrong, and things do go wrong, we're going to talk about some of the more common symptoms you may run into. So that way, when you hear the water gushing at 11 o'clock at night, because irrigation systems know when Home Depot closes, you have a pretty good clue as to what's going on and how to take care of it. So let's go ahead and get started here. So one of the things we have to remember is these automatic irrigation systems are mechanical, and that means we do need to maintain them. Just like our cars, you got to change the oil, you got to rotate the tires, all that good stuff. Really what's going on is your maintenance is going to be taking care of and catching most of your problems before they become big problems. Especially with drip irrigation, some of the things about it can be very sneaky just based on how the system actually operates. So I do hate to tell you that installation is only the beginning, because without maintenance, plant health can suffer, sometimes to death. If you're not paying attention to what's going on, emitters get clogged up. You know, it's just kind of the nature of the beast. It's a very, very small opening in that emitter to slow down that water delivery to as little as only 1/2 gallon of water per hour. So those emitters can get clogged up, and you want to be paying attention and inspecting them so you catch it before that plant goes into stress. The system can deteriorate to the point where replacement is the only option. And I've heard people over the years actually say with a straight face that these polyethylene drip tubing systems that we use only last about 10 years. That's absolutely nonsense. Polyethylene is not biodegradable, but a poorly designed, poorly installed system with zero maintenance, then yes, you do have a 10-year system. Just as an example, the house I'm in right now was built in 1990. The front yard drip system was put in when the house was built, and it is still the original poly tubing out there. Wasn't a great job because it's one valve that waters everything, but it is still the original poly tubing. And of course, your irrigation system is going to be the most efficient as it possibly can be, probably on the day that it's installed. And if you're not taking care of it, it's going to become less and less efficient, which means now you're going to have to increase that runtime to cover up that inefficiency. And that's just going to be wasting water, putting out more water on the parts that are getting adequate water to begin with, just to compensate for the weak areas. So kind of start to finish, here's a little schematic of what we're looking at with kind of a drip irrigation system going on here. So usually the water source is coming in from your water meter from the city, coming up on here, and it goes into your house. And then you're going to have what's called a backflow preventer. What this does is it makes sure the water, once it goes into your irrigation system, it cannot come back into the drinking water system. And that is very, very important to make sure you've got that done correctly. So we're going to talk a little bit more about that later on. With this style of backflow preventer, it does allow us to put our valves underground in these boxes so we don't have to look at them. As an irrigation guy, I understand that. We go to great lengths to hide these irrigation systems. And as a matter of fact, 99.9% of your irrigation system is actually below ground, but it also keeps them protected. And with the drip irrigation system, they do operate at a lower pressure. So you're going to have a pressure regulator and then a filter in there to protect those emitters from getting clogged up. If it's an automatic system, that valve is going to be connected by wires back to that controller hanging on the wall. And then when you exit the box, you're going to transition to that flexible poly tubing, putting in your emitters wherever you may need them. And then at the end, you want to have the ability to open up the end of that line and flush it out. So you want to make sure you can do that. So kind of a start to finish schematic there. And I got to re-click on the slide. So let's talk about our drip irrigation maintenance. Some things we do need to bear in mind is drip irrigation requires not necessarily more maintenance, but it can take a little bit more time to maintain because it's not as obvious as a sprinkler system. The components when you're using the poly tubing are a little bit more fragile than that hard white PVC pipe. But the benefit you get out of using the poly tubing is it's much easier for people to adapt and modify later on as their plant palette changes or as the plants grow, and we'll talk about that. But if you don't know where your tubing is and you're digging a hole, I actually recommend you have the system on and running when you're doing that, because it is a universal reaction. It crosses gender, nationality, even religious beliefs. Anyone on the planet digging a hole in the ground that all of a sudden has water gushing out of it always stops digging. It works every time. Now you know you've got to do a repair and you've got to flush out all the dirt that you just got inside that system. And because it is a low pressure system, those problems are going to be a lot more subtle. If you've got a broken sprinkler head in your yard, you're going to figure that out really quickly because you have a 20-foot geyser of water shooting out of the ground. Drip irrigation does not create 20-foot geysers when it has leaks. So you've got to get out there and actually walk around and look at it. So let's talk about some of our different maintenance regimens we want to do. And this is one advantage of doing these courses remotely, because here I'm going to talk about daily system maintenance, and now none of you can throw anything at me. I'm really not telling you to do anything about the system. I'm just getting you used to the idea that you just want to pay attention and see what's going on. So number one, obviously, look at your plants. They're going to tell you what's going on if they're being underwatered. So if your leaves are turning brown and curling up, that's probably a good sign of underwatering. If you're looking at your lawn, which we're really not talking about tonight because this is just drip irrigation, but your grass will start to turn that kind of off color, almost a bluish gray. And it'll also do what we call footprinting, where after you walk across it, the grass does not spring back up. The footprints remain. Now, some signs of overwatering are the new leaves at the very ends of the stem start drooping, especially in the afternoon. And this one confuses a lot of people, excuse me, because they assume it's underwatering and they start adding even more water to it. They're just making the problem worse. And if you're looking at your lawns, it's going to start smelling a little musty. It's going to be squishy when you walk across it. So definitely want to pay attention to that as well. The other thing you're going to do for daily system maintenance is just pay attention to the ground. You've got your plants out there, but you don't have 100% of the area covered in plants. You've got some open areas, and those leaks are going to be easy to spot. So look for any washed out spots. So here we know we've got a drip irrigation leak, and that system is not even running. I did not have to turn that system on. I recognize that right away where it's got a washed out spot, and then you can actually see the soil is washed out and is now on top of the granite. And also look for where you might have some wet spots where there's no emitters. So now it's time to turn on the system, find out what's going on, and make your correction. So the other thing you're going to want to do for your daily system maintenance is look at your hardscape. And what you're looking for is the staining from the minerals we have in our water. We do have a slightly hard water. It's not a real hard water, but we do have some minerals in there. Most notably, when we're thinking about things that might stain our hardscape is calciums and salts. So you're going to want to look at your sidewalks, your driveways, pool decking and patios. And the example I show in this photo is done with sprinklers, but it's kind of the same idea that you want to pay attention to, where I don't even have to drive. I don't even have to turn that system on. I know exactly where every single sprinkler head is there, right there. So those are the larger heads that rotate back and forth, and they've got them out of adjustment, and they're spraying onto that nice colored block wall, which is unfortunate because you've got the choice now where you either paint it, which then why did you spend all the extra money on that nice colored block, or you're going to wash it with a muriatic acid solution, which means when that runs down off the wall and into the grass, you're going to kill the grass. So you're going to have to wait for it to fill back in. But you can see the same thing happen with drip irrigation with leaks where it's going out onto your patios and things like that and sidewalks. So once you see that white staining, it's time to turn your system on and see what's going on. And I got to re-click on my screen here. There we go. So for monthly irrigation system maintenance for these drip systems, you're going to start at the controller. Couple reasons you're going to do this. Number one, you're going to make sure the program is appropriate for the season. It's up to us to change those watering schedules as the weather changes. If you don't touch your irrigation timer ever and your landscape is living, that probably means you're either watering at summer water needs and the rest of the year you're overwatering, or you're underwatering in the summer and you've got super, super tough plants that are doing something that most irrigators don't want you to know about, is there are plants out there that actually survive on rainfall. Now, this last summer was pretty tough for those types of plants because we didn't have any rainfall. But really what's going on is you want to turn that system on and you want to do it at the timer. A couple reasons for that is number one is you're still standing up and you're dry. So that's always a good thing. So we run our irrigation systems at night so we're not losing that water to evaporation. Turn it on in the daytime rather than going out at 2 o'clock in the morning with a flashlight. So for monthly drip irrigation maintenance, you're going to go out there, turn the system on and actually walk around all around the yard, looking at all the plants, looking for any leaks or damage to the emitters, the connectors, or the tubing. And you're going to want to make sure your emission points are still visible. So you'll see that little 1/4-inch tubing that we call spaghetti is still sticking up above the ground. You don't ever want to let your water out of your irrigation system below ground. Oops, I didn't erase my thing there. There we go. Let's clear that. And clear that. Okay. So if your system was installed where that poly tubing wasn't buried deep enough, you can actually see it walk itself back out of ground. It is a flexible tube, so every time it turns on and pressurizes, it kind of wiggles a little bit. And sometimes those people, I understand digging is hard, but they'll only install that tubing about 2 inches deep. You really want that tubing about 6 to 8 inches deep. That's going to make sure it stays in the ground where it should be. And it also means it's going to last a lot longer. We'll hear a lot of people talking about where that tubing gets those lengthwise splits on it. You patch in a new piece and it keeps happening over and over and over again. And all the times I've been able to go out and see the systems where that's actually happening, that tubing is buried much too shallow. And there is a big difference in the soil temperature between 2 inches and 6 to 8 inches. So that shallow buried poly tubing is going to just dry out and desiccate and become brittle and start causing leaks on you. And even a successful gardener will have plants that die, and you may actually not want to go out in the middle of June and dig a new hole and put a new plant in the ground. You can plant anytime. Landscapers work year round here. But it's going to take some serious changes to your watering regimen for the rest of your landscape to be sufficient for that new plant. So what you can do is you can put in what's called a goof plug, and I'll show you one in a little bit here when we drop out and actually start showing you pieces. But that little guy right there, that's a goof plug. It fits right inside that 1/4-inch tubing. And then all you do is in the fall when you really do want to plant, because it's more comfortable for you. And with most plants, that gives them their first winter to get well established before they hit that first hot summer. So on an average yard, you're talking about a 3 to 5 minute walk at most around the yard. But again, you're walking around looking at every single plant. Don't try and do a drip irrigation inspection from the kitchen window because you can have lots of leaks out there and you're just not seeing them. Okay, let's click on that again. There we go. So for semi-annual system maintenance, about twice a year, and a real easy way to remember this is by doing it around Memorial Day and Labor Day, is you're going to actually think about replacing that backup battery on that irrigation controller. And most of them use a 9-volt battery, and they're usually somewhere in the back on the back panel, or they may be even up in here somewhere. But do check your manual to see what type of battery your timer needs, because some of them use a rechargeable battery. And if that's the case, every 6 months is too often to replace it. What's going on there is the controller is constantly trickle charging that battery, which means do not put a regular alkaline battery in there. It's just going to cause a bad chemical reaction, explode, and you got a big toxic spill inside your controller. The manufacturers tell you to do it once a year, but they don't live in Arizona. The other thing you want to do is go ahead and inspect your valve boxes. Like I said, we go to great lengths to hide these irrigation components. They're not as pretty as the plants. Even as an irrigator, I have to admit that. You know, the plant people get all the glory. Us irrigators are merely tolerated because you need us. But actually turn the system on, open up those valve boxes, and make sure you don't have any leaks inside there. clean out any excess dirt. So a lot of times those boxes get filled with dirt, and actually you don't want your valves buried down in the dirt, because if you do have a small leak in there and your valves are buried, there are some things in your yard that are attracted to moist soil. And before you think termites, think about the entire reason why you put in an irrigation system to begin with. Roots are attracted to moist soil. It got too old and dried out, so it crumbled, so I don't have it anymore, but I used to have an irrigation valve that I removed that was completely engulfed in tree root because it had a very, very small leak that never came to the surface, but that valve was also buried in the soil, and that tree root found it and just started growing around it. It was literally, over the course of time, if we didn't catch it, was going to rip that valve apart. Also, check out your wire connections inside there. So what you don't want to do is have those wire nuts making those wire connections. And while we're here, what I'm going to do is I'm going to start my video, and then I'm going to stop sharing so you guys can see me. Okay, oops, I got a Q&A box sitting over there. Okay. So the majority of residential irrigation systems we see out there, they're using this multi-strand, individually insulated thin gauge wire out there. And unfortunately, what we see way too often is people make the wire connection between the valve and the wire going back to the timer with a plain and simple wire nut. So you're just stripping off a little bit of insulation off the end of each wire and twisting that until it's good and snug. That is a good wire connection. The problem with this is when it's down underground in that box with that lid on it, there's a very high moisture content in there, and the bare ends of that copper wire is exposed to that environment. So what's going to happen is they're going to corrode. And it's a very low voltage signal coming from that controller to tell that valve when it's time to turn on. That corrosion there will make it so the valve never gets the signal and it doesn't open. So what you can use, they do make those wire nuts where they're filled with silicone. This one's much larger than what you would normally use. I use it so you can see what's going on, but you'll see it's got these flanges down here to hold the silicone in, and you use it like a regular wire nut, stick it on there and twist it. Now, when we teach contractors how to do this, we recommend they don't use these, because if anyone ever does need to replace that solenoid on the valve, they're going to take this off, replace the solenoid, and then they're going to put this right back on. But now it doesn't have all the silicone in there. It's just a standard wire nut, and you're going to get that corrosion. So for the contractors, when we tell them to do their installs, we're telling them to use these more commercial grade waterproof wire connectors sold under the name of either Pentite or Dry Splice. So mine's not fully assembled, but you bring your two wires up in there, twist them together. You'll see there's that copper collar on there. You want to crimp on there. And then you have a cap that's normally filled with silicone. And you snap that together. So over the course of time, you'll never be able to take that apart the way I just did. It forces them to cut off that wire connector and then reuse a new one. So let's kind of show you what your valve looks like when you're looking down inside the valve box. The way you're normally going to identify which one is a sprinkler valve and which one is a drip valve is here we've got our valve. Your drip valve should have this filter assembly on it, and it should also have this pressure regulator on it. So the filter is going to protect your emitters from getting clogged up. Now, some people say, well, you don't need a filter because you're using that clean city water, and that water is very, very clean when it comes from the treatment plant. But how many miles of pipe does it go through before it gets to your house? How old are some of those pipes? So you can get some material flaking off in there. Your filter is going to keep that from getting out and clogging up your emitters. Most drip irrigation systems are happy between about 20 and 30 PSI. So very commonly we use 30-pound regulators. But like I said, these are buried underground in a box, and it's all sorts of connected different pieces. Each one of these is a potential for a leak. So let's go ahead and reshare my screen. And go back to there and share. And then stop my video again. There we go. Okay. The other thing you want to do for semi-annual drip maintenance is make sure the emitters are correctly placed. When you run your drip system, you are not watering plants. Stop thinking that way. You are watering roots. And once you start thinking about that, all the stuff we're saying is going to start making a lot more sense. So what's going on here is when the trees are first put in the ground, and this is actually a very good irrigation design that was a commercial site in Mesa I ran into. What the installer wanted them to do was install one 4-gallon per hour emitter right on top of that original root ball that the tree came from the nursery in. At the time of planting, he wanted 5 more 4-gallon per hour emitters out at the edge of where that future canopy was going to be. Now, after that tree gets established, the idea is to just cut that one off because your large structural roots under here are not absorbing water. By doing this, you're going to do everything you can to encourage that tree to grow nice, big, wide, deep root systems. That's the whole point of what you're doing. You want to definitely get those roots growing. So let's close out on that. Unfortunately, let's click on the screen again. There we go. The installer did not quite understand the concept of what they were trying to do. So we've got 1, 2, 3, 4, 5, and emitter number 6 is on the back side of the trunk of that tree. So the guy just looked at it and said, wow, 6 4-gallon per hour emitters. Okay, boss, I'll put them in. But the other thing you want to look at is just look at that nice white line right there on the trunk of that tree. Remember those minerals we have in our water? Calcium is one, salt is the other. Luckily, that tree happens to be a fairly salt tolerant species, so it hasn't killed it yet. Also look at how moist this soil is, not just from plain overwatering, but where they're watering. When our soil is dry, it's a consistency of concrete. Before we dig a hole, we go out and get the soil wet so it becomes plastic and pliable. Where the tree is anchored to the ground, do you want that soil to be the consistency of concrete or Play-Doh? That's the other reason to get those emitters out away from the base of the trees, especially with new young landscapes. Start doing it 6 months after planting. So what you want to do is water what we call the drip line of the plants. And I'm using trees as the examples, but you do this with the shrubs as well. So that's where the water absorbing roots are going to be on your woody species. Now your palm trees and agaves and things like that, they have fibrous root systems. They'll pick up the water anywhere in the root system. But again, you're trying to encourage a deep, wide root system. You still want to move them out and away. So with your shrubs, it's also easier to inspect and repair them if they're not buried in the middle of the plant where the original planting location was. So if we've got our tree here, and if you think about it, when people are out in the middle of nowhere and it begins to rain, people will naturally gravitate underneath those trees. Unless you're at a golf course, don't get underneath those super huge eucalyptus when it's a thunderstorm. We don't want anyone getting struck by lightning. But out in the middle of nowhere, people will go into the trees, and it's not because it's wetter there. It's actually drier under the tree because what's going on is the tree is doing its own version of water harvesting. It's taken all the water that hits, well, not all the water, but a lot of the water that hits the canopy and shedding it off here. That's what we call the drip line. So let's go like that and click one more. So you'll see that drip line going on there. Let's erase my little notes there. Clear. There we go. So we've got our little drip line there. In nature, the majority of the water absorbing roots for that tree is going to be in this location. The more we mimic the way the tree grows in nature with our irrigation systems, the better off you're going to be, the more successful you're going to be at growing those trees all the way up to maturity, making sure they don't fall over every time the wind blows. So what happens if we don't move them? Well, sometimes we get lucky and the trees just ignore us and they put out their roots anyway and they start finding water in other locations, other emitters, the neighbor's lawn, whatever it might be. But sometimes they don't. And a lot of our desert species have developed and kind of gotten this way over the eons of living in a desert where rainfall is very infrequent. It's during the wet season, they do all their canopy growth, everything up above ground. It's during the dry season, they do their root development. So you've got these trees out there with 3 or 4 2-gallon per hour emitters right at the base running 3 days a week, year round. There is no dry season. And sometimes the tree just does not bother putting out a root system. So this is about a 5 to 7 year old tree. It was about a 20 to 25 foot wide canopy when it was standing up. and it just fell right over. And this was not a summer thunderstorm. This was a winter rainy season, very little wind, but I knew I would still find trees that had fallen over like this. So let's go ahead and look at it. And as I was walking up to it, I said to my coworker, because we were going out purposely looking for fallen over trees to take pictures of, I told my coworker, wow, they spent a lot of money on that tree. They put in a 48-inch box tree. Now it's a 5 to 7 year old tree existing in this landscape. How could I possibly know what size container this came from the nursery in? I could probably take a tape measure and measure an exact 48-inch distance from there to there. Really unfortunate. And if you think about it, we're growing these trees for a very specific purpose. I mean, we like the desert trees. We've got some nice flowering trees, but really the number one reason we want them is shade. If you're replacing your tree every 5 years because you're not irrigating to grow roots and they fall over, how much shade are you going to get out of that tree? That particular tree, you should see a 50 to 100 year lifespan. Now, if you're using something like a ironwood, that should be a 250 year plus lifespan on that tree, not 5 years. Okay, I think I got a couple more pictures there. So you can really see what's going on there with that perfectly squared off edge. Like I said, I probably could have taken out a tape measure and measured it exactly at 48 inches. Okay, for annual drip irrigation maintenance, you do want to clean out those filters. They're in there, they're screens, and they're designed to catch anything that may come through the water system before they get out to your drip emitters. So you want to open them up and flush them and then inspect the filter elements. This particular photo is a commercial irrigation valve installation, so there's only one valve per box. It's got the heavier gauge, 14 gauge wire in there and things like that. So what I'm going to do is I'm going to turn my video back on and I'm going to drop out and I'm going to show you how you want to actually flush these out. So let's do a stop share and let's grab my valve assembly here. So the water is coming in this direction. So you're in front of the pressure regulators. So the water going through that filter is at full water pressure. And what you're going to want to do is open it up before you flush it. Some of the early filters out there, like this one, these you were told to install pointing upside down. So that way, when we open it up, anything that fell into the screen is going to come out with this, as opposed to this way where it would just fall right back in and we're going to clog up our emitters again. But after you flush it out, you're actually going to want to look at the filter screen there. And most of your residential ones are using the ones that have this nylon mesh. Let me hold it up here so you got a little better look at it. I'm looking at the other monitor so I can see what I'm showing you here. So if anything ever got sharp in there and it was wearing on that screen and it wore a hole in it, is this a filter anymore? No, at that point, it's an expensive coupling. So that's why on most of your modern filters out there, they have this flush cap. So what you're going to do is you're going to open up that flush cap before you open up the filter itself, and then you're going to turn the valve on. And in this case, rather than using the timer, you're going to turn the valve on manually at the valve. Many of your newer valves have a lever where you can turn that solenoid about a quarter turn, and that manually opens the valve independent of the controller. You're at full pressure, that water is going to shoot right out of that box. Unless you happen to have a really tight install where the wall of the box is too close to that filter, and now you're going to fill your box up with water in about 5 seconds. And you don't want to get that water level higher than your open filter because you're stirring up all the dirt and the twigs and the leaves and all the other things that live in valve boxes. You don't want that going back into your filter. So if yours is too close and it's going to fill up the valve box instead of shooting out like it should, I've got great news for you, especially if you're the pack rat of the house. How many of you out there have a short piece of garden hose that you won't throw away because it has the good end on it? The thread on these filters is not pipe thread, that's hose thread. So you take your cap off and you make sure your spouse sees you using this, and you screw that on there and you lay the other end out somewhere, hopefully around the drip line of a tree so they can take advantage of that water you're putting out there. Now you can flush out your filter and keep your box nice and dry. After you've pulled it out, that's when you're going to inspect your filter elements, and that's where we talk to you in the design and install class. Instead of using those filters that have those nylon mesh screens in it, we recommend you buy a better quality filter that has a stainless steel mesh screen. This is never going to get a hole worn in it the way those other ones do. Okay, let's go back to share screen here. Share screen. And we're going to go there and share. There we go. And we're going to turn off the video. Okay. Moving right along. Okay. So the other thing you're going to want to do for annual drip maintenance is actually flush the poly tubing. A lot of times it's very common to use what we're calling a figure 8 closure here. It is literally just folding over and kinking off the end of the tubing. The only problem with that is now this is up above ground. It's exposed to the sun where it's going to deteriorate, and sooner or later it's going to become a leak. But on this, all you're going to do is slide this little piece right here down, and I'm going to show you what it looks like in real life in just a moment. And that'll allow the tubing to open up, and then you're going to turn it on. What's going on here is now you have the big open end on the end of that larger poly tubing rather than all the tiny openings where your emitters are. And when you turn the valve on, that water is going to move much faster than normal through the system and carry the majority of the debris right out the end of it. So my preferred way to do these end caps is to put them underground in these boxes like this. But you'll notice that somebody buried this one too deep because they didn't take into account the fact that that granite was going to be installed after they set the box. So we had to go out there and scrape around and find it. And in here, we use the threaded caps rather than those figure 8 closures. So let me go ahead and share my video here. Start video and stop sharing. I'm going to show you what these pieces look like. Okay. So here we go. So yeah, here's that figure 8 closure. All you're doing is just sliding that piece down, which allows that to open up, and then you just turn the system on. So you're going to want to let it run about 2 to 3 minutes, maybe longer if it's a real long system, after you see clean water starting to come out here. So it's kind of like the idea of draining and flushing your water heater on a regular basis, because you're going to get that buildup of all those minerals in our water. And I've actually opened up poly tubing where we've gone out and people have said they've got problems with their systems. There's just not enough pressure, especially at the end. We'll cut that open and this tubing will be more than half full with those white chalky minerals in there. So at that point, it's so clogged up, we probably can't flush it out. And that's where abandonment of the system is your only option. You're putting in a brand new irrigation system at that point. Now, the reason why we don't use those figure 8 closures inside these little round boxes here is because we don't have room to open it up. So that's why we're going to use our threaded end cap here. So on our threaded end cap inside that box, we're just going to open up that cap. Now inside that box, don't forget we're at the end of the line behind that pressure regulator. So what that means is we're only going to have about 20 pounds of pressure. So you do not get a giant geyser of water shooting out of that box. You're going to fill that little box up with water in about 5 seconds. So once again, after you've opened the box and taken the cap off of your end cap here, make sure your spouse sees you carrying this out there. That's hose thread, not pipe thread. So now you can lay the other end of your hose out somewhere by the drip line of a tree so it can take advantage of the water and flush it. If you've been in your home for quite a while and you know that system has not been flushed for many, many years, I want you to be where you can see what the water looks like when it first starts coming out the end. Once you see what that looks like, you will become a firm believer in taking just a few minutes once a year and flushing that out. So let's go ahead and go back to my presentation here. And hopefully I'm not going to have to drop right back out. There we go. Okay. There we go. Now, in many cases, your residential systems, a lot of times they're just going to be like this tree valve here, which we have colored yellow. And it's going to be one long line that comes all the way out here. And there's our flush cap. That's where it should be. But in some cases, you may have more like something going on that's happening with our shrub valve here that's colored in red. You'll see we're teeing off in different directions. So I'm going to have a flush cap here. I'm going to have a flush cap here. I'm going to have a flush cap here. And I'm going to have a flush cap here. If you've got multiple flush caps going on, let's see if I can still, no, it doesn't let me do it until I get rid of my annotate screen. There we go. You're going to do them one by one, and you're going to start your one with the closest one to the valve and work your way out one by one to the farthest one out there. So that means, let me get my little screen going on here. Let's clear these. There we go. So that means I'm going to open up this cap down here, turn it on, and flush it out. Then I'm going to close this cap, and then I'm going to open this one, turn it on, and flush it out. So what that means is now I am only really flushing this part of this line, because this part here already got flushed out with this guy right here. So let's clear those. After I'm done with that, I'm going to move to this one at a time and flush it out. And especially as you get further and further away, after this one is done, when I go to flush out this one, I'm now only really flushing out this segment of the tubing. Everything in front of that has already been flushed out. If you open them all at once, you're just going to have the water barely oozing out. I had to change the color on the slide on this screen so I can show you what these drawings look like. I didn't want to have to redraw them, but this is where you're going to make sure the emitters have enough, or the plants have enough emitters for the size. A very small plant, one emitter, you're covering a good 40 to 50% of that root system. Whereas as your plants start getting larger, if you still only had one emitter there, you're going to get to the point where you're only wetting 1% of that root system. So you're going to begin moving them out out towards the edge of that canopy and adding more in as time goes on. Now the tree I'm showing you here, that looks a lot crazy as far as what's going on, and we still have some under here. Your tree still can have some absorption roots here, and this may actually be a shrub zone. There might be a shrub with an emitter there. Now, do you think that tree, when it puts its roots underneath that emitter that you're calling a shrub emitter, do you think that tree is going to say, oh, I'm sorry, that's not my water? That tree will take it, so pay attention. So this might be one you actually put out for the tree. That one might actually be a shrub one, but it will take advantage of that water. So when it comes to adding in new emitters, let's see, I think I'm going to show you during the repair section how to deal with this as far as extending the lines to move those emitters out and then adding in more emitters. So we'll do all that in one shot rather than right now. Okay. So for annual system maintenance, you may want to consider when your backflow preventer was last tested. So this is that pressure vacuum breaker style that I told you is the preferred way to do it. Now this one, it's actually in the off position right now. So what's going on here is if this handle is parallel with the pipe it's on, it's in the on position. If it's perpendicular to the pipe, it's in the off position. I had this shut off for some reason when I took the photo. And there's also actually another valve here that mine does not have. I don't know where it went. It wasn't there when I bought the house. This is generally the one you would shut off if you need to anyway. If you shut off this one here, this is no longer under pressure. And when you turn it back on, it's going to squirt a bunch of water out of here and you're going to get all wet. So if you ever do need to turn them off, shut it off here. Now, on commercial systems that have dedicated landscape meters, they are required to have those assemblies tested every year by a certified tester. And if they don't do it, and if we remind them and they still don't do it, we will shut off the water to that meter and lock it off and tell them they can't have water for their landscape until they prove to us that that backflow assembly is working and protecting our drinking water system. Now, if we cut off an apartment community's landscape back water meter in June, all of a sudden they get those things tested real fast. You don't need to test yours once a year. That's excessive. And we don't ask homeowners to do it. There's just way too many of you. We just don't, you bury those people in paperwork. We just never see them again. But maybe every 3 to 5 years, you may want to consider it because on this guy down here, if there's a backflow condition, this check valve here opens in the downward position and opens up that vent so water can flow out here. But there's also another check valve down here that's supposed to shut down and make sure no water can go back that way. So if you've had any of these ever malfunction, maybe you've seen them leak under here, you can see how grungy mine is. Obviously, this one at one point was leaking. You can see all the staining from that leak there. You're going to know if this one's malfunctioning. You're not going to know if this one's malfunctioning unless it gets tested. So that's what these two little ports over there, that's what the tester hooks up to, and he tricks that assembly into thinking that the water's running backwards. You can get a list of the certified testers from your water department. Most contractors are honest, hardworking people, but there are thieves and scoundrels out there. So call a bunch of them to make sure you're getting a good, correct price on that. You also may want to make sure that you do have the correct backflow. This slide just got added in on Monday because this was at a house in Gilbert that I went to go visit. This is an atmospheric vacuum breaker, not a pressure vacuum breaker. This style here, that little popping underneath there is not gravity operated. So that means you cannot have valves downstream of it, which this one does. So what's going on now with those valves under there, this poppet is always in the closed position. It does not have the ability to dump water out if it's running backwards, because that is a completely sealed condition when these valves are in the closed position. So what you do want to do is, if you have something that looks like this, and I'm going to pop out of here in just a moment and show you another one that unfortunately we see way too often, is this also is a manual anti-siphon valve. So that little poppet under there, that check valve, is gravity operated. If you've got a valve downstream, this is under pressure, that vent is always closed. The water will just run backwards there. But we'll see people use these saying, oh my gosh, that's a brass one. That's a big heavy duty one. That's the one I should be using. If you've got irrigation valves and boxes downstream on this one, or in the one I showed you in the picture, you want to get it replaced with that pressure vacuum breaker. And it is the city code to do it properly and make sure you're doing it properly. But honestly, that city code is the least important reason for you to make sure your backflow prevention is done correctly. This is really about the safety of your drinking water. So let's go back to share screen here. Yep. There we go. Sure. And video off. There we go. Okay. So now let's talk about troubleshooting. And it looks like we got just over 15 minutes left. Even with a good maintenance regimen, things are going to go wrong. You take care of your car, you change the oil, you rotate the tires, all that good stuff, and the alternator goes bad. It's just the nature of the beast. It happens with everything in our lives. So the first part here on troubleshooting, I'm going to call Why is my controller acting so crazy? Because I worked for a few years for Rainbird at their technical services division, which meant I was in a call center with other irrigation specialists, and people would call the toll-free number when they had problems with their irrigation system from all over the country. We would actually walk through them how to troubleshoot their system and find out what the problem was. So we got to get very, very good at describing what these components might look like and where they might be. But the timer is what people see. So 99% of our calls from homeowners started out with the sentence, my timer doesn't work. More often than not, it's actually a programming error, or the real problem is elsewhere in the irrigation system. So a very favorite call of mine was this poor little old lady thought her controller was under some sort of demonic possession because the irrigation zones kept starting themselves up and running through the cycles over and over again. The cause on this one was not a bad timer, it was a programming error. She tried to outsmart her timer and she lost. She put in extra start times. She thought those individual start times were starting individual stations. On 99.999% of your controllers, that is not how it works. There's a couple oddballs out there that we run into that you truly do set up a start time for each individual station, but very, very few of them. I see about maybe one every 3 years or so. So what's going on here is she wanted the grass to water Monday and Thursday. She had 3 stations watering 15 minutes. Remember, a start time is a cycle start, not a station start. So if you want it to start at 5 in the morning, you put in one start time of 5 a.m. Let me get my little pen here. So at 5 a.m., it starts station 1, runs for 15 minutes, stops. It moves to 2 all on its own, runs for 15 minutes and stops, moves to 3 and waters for 15 minutes and stops. But what she did in her case is she thought the number 2 start time started station 2. It does not. So what happened is after this first cycle of the stations went through, the timer says, oh my gosh, I missed a start time. So it goes back to station 1, waters, goes to station 2 and waters, and goes to station 3 and waters. And of course, in her particular situation, because she had 3 stations, she put in a 3rd start time. Come on. So that means the timer says, oh my gosh, I missed another start time. So it goes back and waters station 1 for 15, station 2 for 15, station 3 for 15. So that means each of your stations watered for 45 minutes. What you use those extra start times for is to control runoff with sprinklers mostly. If you really want 15 minutes, you probably can't run them 15 minutes in one shot without having them run off. So what you do is you set them for 5 minutes, and then you purposely give them the 3 start times about an hour apart. So that means we cycle 5 minutes, soak for an hour, cycle 5 minutes, soak for an hour, cycle 5 minutes. We've now got our total 15 minutes that we wanted, and all the water is soaked into the lawn, not running down the street or ponding in the low areas. Okay, another good one is the irrigation runs at strange times. Comes on in the middle of the day. Often this is a programming error or a power failure where somebody did not replace that backup battery, so it's lost your program. So if it's one of those issues out there, a lot of the controller manufacturers put in what's called a default program, and it's set to run every day, all stations for 10 minutes with 1 start time. And they usually put in an early morning start time, like 7 o'clock in the morning. But when the power comes back to the controller, it thinks it's midnight. So 7 hours later is when your irrigation starts up. So now it's time to go out there and reprogram your timer and then put in a new backup battery. Some of your modern controllers have what's called non-volatile memory. So the backup battery doesn't hold your program. That's just keeping current time and day. Another good one is the controller won't respond to any of the buttons no matter how hard I push it. That controller's had a power surge, so you're going to reboot the controller. No Control-Alt-Delete keys, but what you're going to do is just remove the power. Turn your circuit breaker off or unplug it, whichever way yours is getting power. But what's in that controller to make sure the information is held on that chip if there's no power. Take out the backup battery if it has one. 30 seconds to a minute later, power it back up. If it works, you're back in shape. If not, it's time to go and see if your controller's under warranty where you can get a replacement or purchase a new controller. Another good one is one station won't stop watering. Another favorite call from Rainbird. Guy screamed in my ear, your stupid irrigation system doesn't work. And like I said, we're in a call center, we're in the headphones, just like those telemarketers do. So it hurt my ears. So my response was, no, mine works fine. Sounds like you could use some help. The program on this one can be a programming error. Remember, always check the easy things first. Don't automatically start digging things up. So you've got to be careful of how your particular controller gets programmed for runtime. So a lot of controllers, when you're running drip irrigation and you're programming in hourly increments, it'll say the word H or H hour or even the word hour. But some of them, if you want 3 hours of runtime, it looks like 3 o'clock on the display. 3:00. Resident in Gilbert, his water use went over 100,000 gallons and his grass was underwater. I opened up his controller and said, there's your problem. And he says, what? I'm watering for 3 minutes and 12 seconds. I said, no, you're running your sprinklers for 3 hours and 12 minutes. So check the easy things first. It could also be a valve failure, have nothing to do with the controller. So what you're going to do is turn the controller off. If it's still running, the problem is in the valve, has nothing to do with the controller itself. And that's what that person's problem was. And then we discovered he had a Rainbird timer, but a Longini valve. So we got his water shut off, and then I gave him Longini's number because he was pretty unpleasant to deal with. If one station won't water, the cause on this one, it could be a programming error. You forgot to program in runtime for that station. Anyone who's programmed irrigation controllers, those of us who do it professionally, sooner or later you make a mistake on programming. It happens to the best of us. It could be an electrical failure. That controller is sending electrical signal out to the valve, or it could be a hydraulic failure. The valve is using the water itself to open and close. So you're going to check your programming, make sure that's good because you're still standing up and still dry. Then you're going to go out and manually actuate the valve the way I showed you earlier by turning that solenoid, or some of them have a little screw off to the side called a bleed screw. I'm going to show you how to actually troubleshoot and repair your valve because people are pretty confident and comfortable with replacing drip emitters or replacing sprinkler heads. But if they've got a problem with the valve, they panic. Oh, I need a professional. You can fix your valves, I promise you.
Jeff?
Yes.
Before we continue on, we have a few questions.
Okay, let's go.
So the first question, what is the maximum length of poly tubing including the teed off runs on one 20 to 30 PSI valve?
If you're talking about that trunk system, the way we showed on the shrub valve, where it was going in multiple directions with T fittings, you really don't want to go more than 200 feet from the valve to each of those end caps, and you measure those individually. Now that's if you're using the full water capacity of that tubing. If you're less than that, you can actually go further, but if you're going to do that, I recommend you have an irrigation expert do some pressure calculations on it to make sure it's going to work before you put it in the ground. Because if you can make those corrections before you put it in the ground, you do it with an eraser, not a pick and a shovel.
And then we have a follow-up question to that as well. Is there a maximum length for spaghetti tubing between the poly tubing and the emitter?
Generally, if it's after the emitter, you really don't want to go more than 6 feet. And I am going to show you when we do some, show you how to put emitters in tubing and stuff like that. I'm going to show you some different ways of installing your emitters and different reasons why you do it. And I see another question about rabbits, and we're going to cover that too.
Awesome.
Okay. So none of the stations of water could be a programming error. You forgot to put in a start time for that program. It's not going to run the stations. Could be an electrical failure or hydraulic failure. So check your programming. If it's affecting all of your stations and you have a rain sensor on there, make sure that's not either malfunctioning or somebody accidentally got it wet. The sensor doesn't know the difference between rainwater and hose water. So then go out and manually actuate the valves. So step one, is it electrical or hydraulic? Manually activate the valve. If the valve opens, the problem is electrical. If not, it's hydraulic. So what I'm going to do is I'm going to turn my video on here, and we're going to take a valve apart for you and do our stop share. So here you've got a typical irrigation valve. Now here, that little lever we showed you on the other one was real big to manually activate it. That's called an internal bleed. If you don't have that, it'll also have this small little screw right there, where you open that guy about a 1/2 to 1 turn and water will spit out. That'll manually activate the valve. The big knob on here is the flow control that controls how far the valve is able to open. So what you're going to do is manually activate the valve. If it doesn't open, then you know it's hydraulic. If it doesn't open and it's electrical, then we're going to show you that in the slides in just a moment. I think I jumped ahead of myself a little bit here, but we'll do this while we're here with the video. So you're going to turn your water supply off and go ahead and take out all of your screws that are around the tops of these valves. I've only got 2 here, so I can do this quickly. Actually, let me take off my solenoid first. If you've got a solenoid or a valve that allows you to turn the solenoid to open it, there is a spring-loaded plunger in there, but it won't fall out. If your valve doesn't let you turn the solenoid to manually open it, that plunger will fall out into the valve box, so just be ready to catch it. And you're just going to gently make sure that that plunger moves freely. It is spring-loaded, so now let's get the valve apart. There we go. There is a spring in there, but it's not going to come out and hurt you. It's a very small spring. And then the only other thing inside that valve, let me set this down, is the diaphragm. So what's going on is if the valve won't close, it's probably a rip or a tear in the diaphragm. If the valve won't open, it's probably the plunger on your solenoid has got grunge in it and it's not lifting up with the electrical signal. Or let's see if you can see this here. See that little hole right in the middle underneath where that solenoid is? That's called an exhaust port. If that is clogged up, the valve will not open. It's just that simple. So let's go ahead and go back to share screen. Oops, it's only 5 minutes left. May not make it in an hour, guys. I tried as hard as I could. Okay, so if it's an electrical valve problem, if it won't open, you got to check those wire connections first. Don't wait for that to fail. Go look at your valve boxes after today in the daytime and make sure you don't have those wire nuts out there. Cut them back to clean copper wire, put on a waterproof wire connector. Could be the controller not supplying voltage on that terminal. It is a failure, but it's pretty rare. It could be the wiring between the timer controller and the valve is damaged. That's harder to find. You may need to find an irrigation professional to help you out with that. Or it could be the solenoid is bad. They do go bad, but unfortunately, most people automatically replace a solenoid if the valve won't open. And a lot of times it's just a bad wire connection and they've just cleaned up the connection and then have thrown away a perfectly good solenoid. If the valve won't close and it's electrical, it's a programming error, or that controller is constantly supplying voltage to that terminal. Very, very rare that we see that happen. So if it's an electrical valve problem and it's only affecting valve number 1, that means it's either this solenoid, this wire connection, or this wire. But if it's affecting all of them, then it's probably this common wire. See how this common wire is connected to one wire of all the valves? And actually, they're almost never daisy chained like this. They're all usually brought into, let me erase that. That's getting a little messy. They're usually all connected into just one connector there. So it would be that connection or this wire. Pretty simple. Okay, oops, let's get rid of that. Okay, hydraulic valve problems. Like I said, oh, that's one thing I didn't tell you about is before you go digging up your valve box, make sure somebody didn't shut off the water supply first. You may have had a leak out there and your neighbor wanted to be nice so you didn't have a giant water bill or a big muddy mess out there. He turned your water off and then he forgot to tell you about it. Look for the easy things first. Could be dirt or debris in that valve in that port I showed you. If the valve won't close, it's dirt or debris in the valve, not allowing that plunger to go back down and seal that port, or there's a hole or tear in the diaphragm. Just that simple. So why aren't my drippers dripping? Single emitter failures. If it's a clogged emitter, remove the old one and put on a new one. So we're going to show you here in just a moment what these emitters look like. And actually, let me go back to my annotate screen, and I still got a little dot there. Clear all drawings. There we go. I did it again. The joys of learning to do these things remotely. Okay. Single emitter failures, if they're blown, they're putting out more water than they should. Same thing, remove the old one, install the new one. So we're going to go through these fairly quickly, and then I'm going to show you live on video how to put in these emitters and why you would do it different ways, and then show you how to do actual tubing repairs with couplers. Multiple emitter failures, clogged emitters. You've got them all clogged up, cut them all off, turn the system on, and hopefully you just had bad luck and had a bunch of clogged emitters. Definitely flush that line. You've got some dirt in there somewhere and you want to clear it all out. Hopefully you don't have to go back all the way to the poly tubing and install new 1/4-inch spaghetti lines and abandon those old ones. And then go ahead and install your new emitters. Multiple emitter failures, pinch tubing. Sometimes we are successful in growing tree roots and it'll grow in the area next to where that tubing is. And as that root gets bigger and bigger and bigger, it can pinch off that tubing, which means now all of a sudden those last emitters aren't getting their water. The only way to find that is to dig between your last good emitter and your first bad emitter. Go ahead and put in a new section of poly tubing, cut out the bad one, and reroute it away from the tree root far enough so it won't do it again. Do not cut the tree root. The root is what holds the tree upright in the ground, and it's what brings in the water and the nutrients. Move your poly tubing away from it. Don't cut tree roots. Okay. Another good one is blown emitters, where all of your emitters are flowing too high, assuming you're not using those cheap flag emitters that put out water in streams instead of drips, or they're actually popping off the ends of the spaghetti. You could have a malfunctioning pressure regulator back at the valve, or you may have a system where somebody didn't put in a pressure regulator. Unfortunately, we see that happen way too often. So we're going to show you how to test that and replace that. And what I'm going to do is I'm going to go back to video here and stop my share. So let's talk about emitters and how we put them in. Let's try and get some emitters up here and some connectors and a goof plug for you to see. Okay, so what you're going to do is a lot of times what people will do, you do want to use a hole punch. It makes the right size hole for the emitter. Don't use a nail. So what a lot of times people will do is they will put that emitter, and it's cool in my room, so this is real hard to do. There we go. And then they will put on what we call the spaghetti line, that little 1/4-inch tubing, and bring that back up above ground. So you've now just got the empty endless spaghetti. This is fast, easy. The only problem is when this emitter clogs up, notice I didn't say if, I said when, you've got to dig this up. You've got to pull that old emitter out. Do not reuse that hole. It's too big now. You goof plug it, make a new hole and put it in. So I'm going to pop that guy back in for you. A good way to do it a little bit differently is go ahead and make another hole here. And now we're going to use this little 1/4 inch connector. And there is no restriction there. That is wide open. So here we've slowed down the water with the emitter. And if you've gone too long with this spaghetti, it takes too long to flow out the end, whereas this does not restrict it at all. So this is how we want to put it in, especially if we want to go farther with our spaghetti line. So now we're going to put our spaghetti line on there, and we're going to put our emitter at the end, up above ground. So there we go. So now our emitter is up above ground, and if it goes bad, we just cut it off and put the new one on. Now I saw somebody asked a question about rabbits. So if you need to want to go some distance away from your tubing, you shouldn't have this right next to where the plants are. Otherwise, when they get mature size, this is going to be under the plant. And if you have to do any repairs, you've got to butcher your plant. Remember, there's a way to attach that spaghetti line to the output side of that emitter too. So you're going to run this out until just above about where you want to bring it above ground. And let's do a little shorter piece here. There we go. So we're just going to take a little short piece, put it on the end. And now we're going to bring that up above ground. So that way we're not letting the water out below ground. Now the rabbit can chew this down to the ground. You're still controlling the flow with the emitter here, but it's not all the way back at the tubing itself. It's much closer to the surface, only a couple inches deep and pretty close to where it's coming out of the ground. So that way it's not too much of a problem to repair it. So now when it comes to doing poly tubing repairs, this is a great thing. See how easy it is to do this? If you've got a hard pipe PVC system, now you're cutting with PVC cutters, you're gluing in new fittings and all kinds of crazy things, whereas this is a lot easier to manipulate. So when it comes to cutting the tubing, you can buy these fancy tubing cutters. Most landscapers are just going to use their pruning shears. So no special tools or saws. You're just going to cut it off wherever you need to. And then what you're going to do is you're going to put it together with what's called a compression coupling. This is a slightly smaller size hole than the size of the tubing. So what I'm going to do is I'm going to line them up, and with a little bit of a rocking motion, there we go. Remember, it's a low pressure system. That is enough of a seal to make a watertight connection. You don't have to get it all the way in. Just make sure you get it in about 1 inch or so. And if I pull this back out, and I am a couple minutes over, I see, I'm sorry. If I hold that up, hopefully kind of close, you can see the end of the tubing now is actually slightly smaller. This does take grip strength to be able to do, and actually when I'm holding it up against my chest, that's cheating, because in the real world, you're working underground in a trench. What you don't do is use WD-40. WD-40 was designed to be a solvent for cleaning aircraft parts, but the carrier is slippery. That's why it makes our door hinges stop squeaking. It will eat through the tubing. Also, as you're putting it in, make sure you don't accidentally kink the tubing. If you do that, cut it further back and put in a new piece. Don't try and make it round again, because when you're tamping the soil down to get it back to compaction, that kink is remembered. It is still there. So now you don't have the water going out to your emitters. If this is difficult for you, there is another type of coupler out there. I mentioned I worked for Rainbird, but I do like other companies' products as well. But this one is made by Rainbird. This is called the Easy Fit coupling. And you see those little white things on the inside there? This is not done by shoving the tubing into a smaller size hole. This is working like the old finger handcuff trick. So it's actually grabbing the tubing from inside, which means when you do make your cut, make a nice, straight, clean cut. So make sure your pruning shears or whatever are nice and sharp, because if they're not, grab my pruners here. Let's say my pruners are very dull and I go to cut through it and I have to kind of work my way and chew my way through it. See that ragged edge on there? As soon as I put this together, it will start leaking. So what you want is a nice, sharp, clean cut. And I can literally put these together with 2 fingers and a thumb, 2 fingers and a thumb and put them together. Notice I'm not putting them together because once you put these together, you're not taking them apart again, ever again. Now these couplers do cost about twice as much as your standard poly coupler, but the last time I checked, these were about 80 cents and these were $1.60. These can be worth it if you have a hard time putting these things together. One last thing I'm going to talk about is with things like T-fittings where you're going in different directions, do not bottom out that poly tubing to the bottom of the T-fitting and then wonder why you're not getting water out the other side, or at least not very much. Let me go back to my presentation. I've got blazed through these screens here real quick where I just described what I just showed you. And turn off my video. Need more help. This is a very short course, even though I did go a little bit over. I'm sorry about that, but do remember your irrigation supply stores. I have nothing against the home improvement stores, but those guys that work at the irrigation specific stores tend to have years of experience in the real world working on irrigation. They're going to be a great resource for you. So Ewing, Horizon, Site One, and Sprinkler World are the ones we have around here, and they've got branches pretty much in every city in the valley. Also, remember the irrigation manufacturers' tech support lines. Call them as often as you want. I don't work there anymore. And their websites. And I think in the handout, I've got their phone numbers. And here I just list their websites. Easy enough. Rainbird's easy to find. Hunter, your search engine of choice will get you there. Hunter and Irrigation will bring you to hunterindustries.com. Toro's very easy. And then Irritrol is irritrolsystems.com. And if you've got a really old timer that says Hardy on it, it's Irritrol Systems. It's just a new name of the company. It's the same company. They just changed their name. So you can download things like your controller manual. So you can get that because that's probably long gone. You can read information about the actual irrigation components you're using, making sure those emitters are actually pressure compensating emitters and things like that that we talk a lot about. That being said, I'm on my last slide, and I believe Jill wants to share a slide with you that shows the links to where you can get to and request their different publications, the water conservation publications. So you ready, Jill?
Yes.
Okay, I'm going to stop a share and then you can do your share.
All right. So just so that everybody is aware of some of the resources through our office, if you have any questions as you think through all of the things you heard, we do have an email that you can reach out to us, waterconservation@scottsdaleaz.gov, and then a few pages of interest where you can find additional resources, our rebates, additional books, and then some interactive watering guides. So with that, I don't know if anybody has any additional questions for Jeff, but now would be the time. While those are coming in, just to let everybody know, we are, as you probably are aware from the little recording icon on the top part of the screen, this will be posted later. We have our IT that needs to kind of cut off the beginning and the end bits of the workshop, but this will be available on the same website that you registered for the workshop if you want to revisit anything. I'm assuming everybody is furiously typing questions, so we'll give you a minute or two. Okay, we have a question. Jeff, I know you mentioned for the setup for the spaghetti tubing, but I don't know if there are any additional suggestions for the dealing with spaghetti loving thirsty rabbits in the dry months.
Well, that's where I was showing you to put that extra little piece on the output side of the emitter, where your emitter is now still buried underground, but still very close to where it's actually going to come above ground. So that way, if that rabbit does chew on the spaghetti that's sticking up above ground, your emitter is still in front of it and intact, and it's still putting out the right amount of water. So you're not going to have those little mini geysers going on. So let me show you here. I think I've still got it attached. So what we've got is we've got our spaghetti coming from there. We've got our emitter here. We're still only about 2 inches below ground. And then at the very end, we bring it up. So this right here is just a couple inches below ground. Now the bunny rabbit can chew this to the ground, but your emitter is still intact, but it's not all the way back at the tubing, so it's still easy to get to and replace. Hope that helps.
Thank you. I think you covered everything so well that everyone is speechless.
Well, don't forget those other resources. Definitely the irrigation manufacturers' websites and those irrigation supply stores. Those guys generally are very helpful and very knowledgeable.
Well, thank you all for joining us. Sorry we're ending a little bit late, but we appreciate you coming to learn about drip irrigation. We are going to be having a few additional workshops in the coming weeks, so check out our website to sign up for those if you haven't already.